Okay, guys, we're going to start our next unit here on electric circuits. To do that, we first need to talk about the different types of circuits that we have in our basic electronics. Okay, so there are actually three different types of circuits that are available, and all more complex circuits actually kind of derive from these three. Okay, so what we look at when it comes to our circuits, the biggest thing we look for is how many paths are available for the electrons to flow through. Okay, if they only have one path to flow through, we call that a series circuit. Now, in previous lessons and previous units, we've been mainly dealing with series type of circuits with a single path of electrons only having one way to flow. Okay, so this one should be most familiar to us. However, it is possible that we have multiple pathways that the electrons can flow. Okay, so think of like a garden hose, where if you have a single hose coming out of a spigot from your house, it has a single path. However, if you put a splitter in it or a Y connector, you actually could get water to run to different places or different locations. You could have multiple pathways for that water to flow. So in that case, when we have multiple pathways, we call those parallel circuits. Okay. And then finally, we have what we call network circuits. Now, network circuits are probably the most common thing you're going to see in advanced electronics because the network circuits allow for the most complexity. Okay, so a network circuit, what it is actually a combination of series and parallel. So you have parts of the circuit that might be running in series where electrons are always forced through a single path, and you have parts of your circuit that they're allowed to go through multiple paths. Okay, so when you combine locations that have a series component to them and a parallel component to them, anytime we do this, we call them network circuits. Okay, in this unit, we will study all three of these and do the math behind all three of them. Before we can do that, we need to get some basic symbolism for us to be able to draw the actual circuits, because that is one of our learning targets for this unit, is to be able to draw them. Okay, to do that, we do wiring diagrams. All right, and those wiring diagrams, what they do is they show us a pathway for our current to flow. All right, so when we do that, we want to have some basic things to write. If we have a wire that's connecting things, we just use a solid line. If we have a battery or some sort of source of electric potential, we use a line with a short bar, always to the negative side, a long bar to the positive side with a gap in between. Now, if you have a battery that has multiple cells to it, okay, so like for example, in a car battery is a 12-volt battery, but it has 6 different cells inside of it. Each cell produces 2 volts for a total of 12 volts. If you saw the symbol for a car battery, you would see a pack of short, long, short, long, short, long, short, long 6 times to represent the 6 different cells in that battery. Now, for our purposes, we don't need you to count cells. As long as you do a single, short, and long, we know that that overall means a source of power for us. But just realize if you ever read circuits in other places, you might see a stack of these in sequence. And what they're doing is representing multiple cells or multiple batteries put together. Okay. Another example would be like your calculators. Calculators that don't have a charging port that you still put the AAA batteries in, they take 4 batteries. Those are actually 4 cells of a battery, because each one of those little AAAs is a single cell. So in that case, you actually would do this 4 times for that kind of deal. Okay. Now, in a circuit, we're trying to power something. And whenever we want to try to power something, that device has some sort of resistance to it. To symbolize resistance, we put in a jagged line inside of our circuit. Okay, that represents a basic resistor. Now, in modern circuitry and in more complex diagrams, we have different symbolism for every type of resistor out there. Okay, so motors have their own symbols, lights have their own symbols, diodes have their own symbols. Everything has its own special little symbol. Again, for our purposes, we want to stay pretty generic here. So generically, we're going to say that anything that we power up or anything that provides dedicated resistance in our circuit, we're going to use this symbol for it. Okay, so we're just generalizing a little bit here. Okay, so any light bulb, heaters, motors, speakers, everything, we're going to use this symbol for it. Okay, just realizing that if you look at a real circuit diagram of something you see in the future, every little squiggly line is not necessarily, a light or a fan, that kind of stuff. They'll have additional symbolisms for those to be more specific. And then finally, we need switches. Okay, an open switch is something basic where you just have the line broken with the space here. Usually this is open also. And then a closed switch looks like a line with a dot on it, but basically if you imagine this thing being closed down, that's now your closed switch. Okay, These four things are enough for us to draw basic circuits in here, and we'll be using them a lot in our future video lessons. Okay, we're going to stop right here because in the next one we're going to dive deeper into what series circuits are and how we use them mathematically. Thank you.